about 25 years ago, was trying to look at the idea of how do we reconnect the urban community back to the importance of agriculture and farming families as the essence of economy. Sorry, I'm being directed. And so that's the whole subject, that's why this thing actually started to take off in terms of production. We came up with this program called City to Soil. We ran a small-scale project in Queanbeyan, where I live, in about 2,500 houses in the year 2001. It worked very, very successfully. The main thing that we were saying to people about contamination in bins, and contamination in an organics bin, this plastic, glass, anything of that metal, anything of that nature that is going to contaminate the compost in the long run. Because the message we gave to people is we need this stuff clean because it's going back into agriculture to grow food for your children and your grandchildren, we had almost no contamination. In all instances, our contamination rate was always below 0.5%. So it's absolute nonsense for governments, local governments or state governments to say that you can't get people to provide a clean product for agriculture. If you can get people to eat McDonald's and drink Coca-Cola, you can get them to do anything. So it's really not that difficult. This program was clearly demonstrating how effective it was. There's only, I think now, this system as it was designed with compostable bags, I think the only place that it's operating in Australia now is in Armidale, New South Wales. However, what we did was when we got to the stage of developing that first program, we actually put some funding into, she's telling me to go that way, you're telling me to go this way. I have to work for the director. I tell you what, you go that way, we'll both be happy. Sorry about that, didn't mean to take it on Vicky over here. So the idea that what happened eventually is we got a $2 million grant to run the City to Soil program out in 4 different council areas. One of the problems that we had in relation to that was if you use the standard compost turning method of making compost, one of our councils is in Condobolin, which was 4.5 hours from Queanbeyan, so you can see very quickly that we would have used all of our money running machinery up and down the highway, so we needed a different compost process. What we came up with was a variation on some work that Sir Albert Howard did in Indore in India in the 1930s. Any of you who are biodynamic farmers will be familiar with that. It was not all that mysterious, and I think in most instances it didn't really rely on any inoculants, but we used that in combination with a compost system that was designed by a woman called May Bruce. May Bruce was a student of Rudolf Steiner's, so the biodynamic stuff. She was very clever in that she felt that one night during a dream she had this concept that you could actually compost things using just the flour and herbal mixtures that were actually already existing in plants. She designed a composting system that basically uses, and you'll see it later in this presentation with a photograph from some work he did in Samoa. So all you do is basically make up a wooden box, as much as you possibly can, a wooden box that's about sort of 2 cubic metres in volume or 1.5, and just layer your material into it, but you're using a herbal inoculant. In the instance in Samoa, we used this inoculant, and we achieved a very, very good quality product. May Bruce's system relied on a cover going on top of the bin once it was full, and you waterproof that. In Samoa, we were using dirt and banana leaves, which worked very, very well, and we produced a very, very high quality compost product in 8 to 12 weeks without touching it, without turning it, without moving anything. So that relies to an extent on getting the moisture right. But the composting process that we're now using, the City to Soil or the Spice composting process, is essentially a combination of those 2 things. This farmer is in Mirrawinny, which is just near Innisfail in Queensland, south of Cairns. His composting site is just at the back of the house, and his wife was mortified when he set the thing up initially because it was right beside the clothesline, and she was mortified about the idea everything was going to stick, including the house. The composting process produces no odour. Now, any of these things that I say that relate to those issues of no odour, let me know if you need a copy, because I can get it to Cheryl. We've done a research project on Mugger landfill that demonstrated this composting process absolutely has no odour. And you'll see when you start to sniff these things later on Some of them have odours, but they're not generally unpleasant. This is very successful. This is just outputs from their packing sheds and from their cropping system. He, I believe, has never had any disease issues since he started composting with this process, I think about 15 years ago. You'll see later on today that you need a cover in this composting process, and all this is the, you know them better than I, they're just the cropping storage, the seed storage systems that you use in paddock. All this farmer did was, the dairy farmers just split one side of it. The benefit of using this product, of course, is it's UV stabilised. If you don't use a UV stabilised plastic product as a cover of the composting process, you'll find that black plastic is very suitable to start with, but it falls apart after about 3 months in the sun. This has been very successful. He's since gone on to stop dairy farming, and he's a full-time composter. I think he takes stuff from 4 different councils. That's Wes Spencer, the gentleman on this side. How the composting process retains moisture. So why would you want to use a cover? And as I said, it's part of the May-Bruce system, but essentially we found initially, if you put a cover, the May-Bruce cover, onto a compost pile and it's an upturned V shape, as soon as it gets to respiration, so as soon as it gets to something like 55 degrees Celsius, it will start pumping moisture. And what will happen when it pumps moisture is you've got that shape, the moisture hits the plastic and runs straight off the inside of the plastic. So what we did was put a little bung in the top, just a dip, and what happens is the respiration hits that dip and drips back into the pile, so you don't lose any of that moisture. I'm just going to explain a little bit further how the composting process works. So because you've got a cover on it, the first phase is entirely aerobic. Nature always uses an aerobic process, so it uses oxygen to break things down, to rot things down as soon as possible. But what we've done here is we've restricted, not closed off, but restricted the air. So it's not a full anaerobic enclosed process. It has access to air. What happens is this aerobic process goes its full cycle. When it's finished, whatever it will consume, the pH changes quite dramatically. It drops to 4.5, quite rapidly drops to 4.5, and the full pile becomes facultative. And the mysterious thing about facultative anaerobes is they'll switch from being aerobic to anaerobic depending on circumstance. And that flies in the face of most of the things all of us were told in primary school about anaerobic things smell, aerobic things don't, which is not necessarily true. But the whole idea of the facultative process is it means the outputs of one process are inputs to another. This composting process, the reason it produces no odour is exactly the reason why it produces no methane. So why we aren't using it all around the world just baffles me. One of the biggest issues of bloody landfill is methane production. So you've got no methane, you've got no odour, you don't necessarily have any turning. And in what you see as farmers later on today, what we'll try to get you to do is, as much as possible, if you use the composting process on your farm, try not to turn it. Try to get the moisture right to start with, and try to get that moisture circulating back in through that pile. So you don't, moisture will be the main reason why you'll need to turn. If you do turn it around 6 weeks to 8 weeks, and if you notice there's some dry parts in it, actinomyces, it'll be a sort of a grey sort of colour. If that's the case, add more moisture and put a bit more inoculant on it, but it'll go back again to the first phase. It'll go back to the aerobic phase and start up again. We're going to get on to some interesting stuff because you're going to be making stuff shortly. Kangaroos. So this is basically, Michael was asking before about a paper, and I sent a copy to Cheryl. This is based, we were using this with a farmer in Bungendore. So the problem that we had at the time was trying to get sufficient green material to put with these kangaroos. And the kangaroos really, they dry out, you probably noticed that kangaroos dry out really, really quickly if you leave those carcasses for long. So what we've done here is mimic the process that's used in this paper on composting goats. So put the animals back to back wherever you can, and then you've got sort of, in the old money, 12 inches of stuff, and then a layer of animals, inoculant on the whole shebang. About 40%, 60% moisture in the material you're using. A similar layer between that and the next layer of animals, and similarly depending on how high you want to go or how high you can go. I think today we're going to be trying to do it about 10 cubic metres. This is the thing in Bungadoor. As you can see, these kangaroos are horribly dried up. I think we ran into a few problems in relation to that. These kangaroos were nominally roadkill. He was having all sorts of troubles with the number of kangaroos that were coming in the fence all the time. But as you can see, the stuff that we got from the council was absolute shit. It was dry as chips before it got to us. There's a regulation in New South Wales that says you cannot move green waste off a landfill site until it's gone through the pasteurisation process. Regulations are very, very important things. The reason for that is they're trying to prevent seeds, weed seeds, getting put out into agriculture. But there needs to be some consideration of how we can get that stuff from urban centres out to farms to get the best benefit out of the product. It needs modification to the regulation, but I'm sure that's going to happen in the future. There's pressure for more stuff on agriculture cuts further. As you can see, it can go to any scale. Some of these are tied down with, well, most of them are tied down with tyres. There are many modifications you can use to keep those covers on, but the covers have to be tight all the time. If you don't keep the covers tight, weather and wind will just basically knock them to pieces in no time at all. It meets the sewage standards and the national composting standard. That's AS 4454. So the stuff that we've used to date, green waste of food, green waste on its own, green waste of biosolids, coal washery waste. This was very interesting. We were able to transfer all the nutrients out of coal washery waste into a high quality compost. Coal washery waste gets thrown away in many parts of New South Wales on the coast around Newcastle and around the Wollongong area. Green waste and fish, sawdust on its own. Well, the sawdust alone, that was interesting as well. That was in the Kosciuszko National Park. We were using sawdust that was about 80 years old. Because we had no nitrogen, the entire pile went to a facultative stage and a fungal stage and stayed there. We didn't get back in for about 4 to 6 months because of the snow, but it made a very beautiful product. Wood chip on its own, manure and straw, and nappies and grass. Nappies and grass is from the work that we're currently doing in Samoa. Sorry.
Can I just ask what makes it a beautiful product?
Just the end process, that facultative stage.
No, but what characteristics of the compost make it high quality?
How do you define quality?
How do you define that it's beautiful?
Oh, humus levels. The CEC are up near 100. The CEC generally, if you look at cation exchange capacity, and I know it's not the be all and end all of everything, but if you look at CEC on the central coast of New South Wales, a lot of soils are around 6, 10, 12, something around that. Consistent with this compost to have a CEC of up between 80 and 100. It has very high humus levels. That's fundamentally what you're focused on. I mean, it's going to have in it whatever you put into it in some ways or other. So.
Can I ask you, there's a term you're using that I'm not quite catching.
Sorry?
When it goes from aerobic to anaerobic?
Yes.
Facultative.
What is that word? Facultative.
Facultative. If you look up facultative anaerobes on the internet, it gives a very good description in Wikipedia.
Could you write that for it?
FAC.
Sorry?
Yes.
Facultative, F-A-C-U-L-T-A-T-I-V-E.
Thank you.
Anaerobe, A-N-A-E-R-O-B-E.
Microexcision function both anaerobically and aerobically.
Ah, right.
So it switches from being anaerobic to aerobic, which is completely utterly counterintuitive. This is what we were using in Samoa. There were 18 young women employed in this project. One of the biggest issues that we've got in the Pacific Islands, and we all have this issue because it's about microplastics, 27% of their total waste stream is nappies. And it's not because they breed incessantly, it's because they give all their food waste and all their food waste and organic waste that's viable goes to pigs and chickens, so it goes straight back into the food chain. So it just pushes up, inflates these figures. What we were doing here, this is a bastardisation of the Made Bruce box. So it's as you can see, it's just a standard pallet. We had to line that initially in plastic. We ended up using mats out of people's huts. But equally, you could use banana boxes if you wanted to do the same thing. We could fill up one of these every, I think, 2 weeks. And by the time it was full, we had them split in two because some of these young women were pregnant. So we had to hinge the thing out so they could get easy access to it. But it was basically that much, because we couldn't get any food waste, it was that much grass and weed, a layer of nappies and a layer of inoculant, that much grass and weed, layer of nappies and inoculant. Now the reason they're using compostable nappies is because you can't give those women a washable nappy in a village situation because they either don't have electricity or they don't have water on a consistent basis. Also too, it gives you the opportunity to actually capture the faeces and the urine as an asset, which no one, to my knowledge, is doing anywhere much at all except in sewage treatment works. Yeah.
Clarify something, you know, with the cover, doesn't need to go underneath.
No,
Yeah.
you're not trying to cut off the air, you're trying to restrict the air.
So that it'd be-
It's not a Bokashi process. Bokashi is one where you're totally cutting off the air supply,
Yeah.
although it's using very similar biology. So this project was put together for the Chobham meeting, Cromwell Heads of Government meeting. King was supposed to turn up, which he didn't do, bastard. He wrote to me through one of his secretaries and asked how the composting process worked. And I wrote back to him and described the process, but also said if he referred to some of his older relatives, they might be able to tell him that his grandmother was actually involved in the Dig for Victory program during the Second World War. That's what May Bruce was using this for food production systems during when Hitler was bombing the shit out of them. So it's very effective, works very, very well. It's quite a simple process. It would suit any community. What we did with these people originally, eventually, is we got them to put 12 of these in a line because there are lots of pallets around. Hopefully what they'll continue to do is fill one up. When that's finished, in 1 week hopefully, because they've got lots and lots of nappies coming, they'll go to the next box, and so they'll get 12 of them and then just rotate back through that same cycle. So it's a very, very simple system, requires and interestingly, I'll show you this later on. One of the young women at one of the workshops we did asked if it was possible to use coconut milk to make lactobacillus, to make this stuff. Yes, it is. There's enough milk solids in coconut milk to make a lactobacillus. So when you get round to this stuff shortly, remember you can do it with coconut milk. But interestingly, this is a hydrolysate that's made on seawater, on salt water. So it means for the Pacific Islands, particularly, we've got a bloody a vegan inoculant. A vegan inoculant, and we can use water straight from the sea to cook it in. I'll talk to you about how we do that later.
So you would put the, after they put the nappies up, and then they put that plastic over each of those boxes?
Yeah, so what they've done is you've got green material, grass that they've gone out and picked, so that further employs them as well. That project's employing 18 women at the moment who've never had jobs before. So that green material, then the nappies and the inoculant. And you keep going, I'll probably go 12 layers in a box up to the top. Then we top it off with soil and put banana things on the top, the leaves. What we had trouble with originally was when you get rain there, it's just bloody unbelievable. So trying to get the idea through them that we need to put a little pitch on the top and put a bit of plastic over the top so the water ran off. They seem to have got that notion now, because if you don't do that in an area where you've got really, really high rainfall and you don't have a cover on it, the water will go straight through and take all the nutrients out.
I'm not sure if you mentioned it, but in climate like this, when you set up the process, you really need to spray water through the,
Just depends on what you've got.
To just get enough moisture in there. So
40% moisture, if you've got something that's dry, and I appreciate that it's difficult to don't have, but at 40% moisture, if you can pick up a handful of it and squeeze it with your hand as far as possible, you should just get drops of water coming out between your knuckles. But you can go to 60% and it won't do any harm.
they want 40 and 60.
40, somewhere between 40 and 60, roughly speaking. And look, this is a real suck it and see process because it's you using it in your circumstance, on your land, in your application. I was saying to Michael before, what we're giving you is a little tool that piles on top of all the things that you already know. One of the things that you really, really have to trust in this process is your judgment. You're already doing that every day because you know how your bank account's going, how your cropping systems are going, what it is, what your market value is, all those sorts of other things, that you trust your judgment to keep you in business. There's a sort of a skill that farmers have got in a very general sense to know when there's a 10% difference in something, and it's that I would ask you to think about when you're using this composting process. If you think something's not going the right way, it probably isn't. So either write to me or, yeah, write to me and I'll try to figure it out for you. This is interesting. So this was using the compost inoculant, which you'll make later on. This young fellow is in Vermont in the United States. That's a radish that was, what did he say? It was less than 2 weeks after planting. So there's lots of things happening in biology where people are beginning to understand what happens when you stimulate the biological nature anyway in a seed, where a seed thinks it's actually sitting in really classy soil. One of the really good examples of that in Australia was with the Haggertys in Western Australia who were growing wheat using just the biostimulant effects of, in their instance, vermicast and compost. I've got one farmer in Minton in Saskatchewan who's been using a combination of my processes and older processes his wife's used for many years. They're on 10,000 acres. He's cut his fertiliser chemical use by 80%. He's making a lot of money, but more importantly, he doesn't use, in that area in Manitoba and Saskatchewan, quite often to stop their crop, they'll desiccate it with zero of Roundup. But instead of doing that, he plants 4 or 5 different species of grain at the same time, harvests them all together, then invested an enormous amount of money in a seed classifier. So he's now totally organic. His daughter started a business where they sell little 1 pound bags of flour for a wholly inflated price. So it's created opportunities in other directions. That's going very well. These people are also using the compost inoculant. I was saying, Michael, earlier, we're waiting on the final research, but they're using the compost inoculant as a preventative for avian flu. And it seems to be very successful. The only reason they say it's successful is because nobody's got avian flu. However, what's actually happened at the same time for them is they normally get a fall off in egg production of sometimes as much as 50% in winter. Their egg production has stayed at 80% right through one entire year, and they haven't had a single mortality. They usually get 10% mortalities in their chickens. Also, there's some good research papers that say if you use a lactobacillus-based inoculant on the chickens, it will increase the nutrient efficiency in the crop by about as much as 1%. And now I suppose if you've got 100,000 birds, that's going to be a lot of money every year.
How are they applying that, Jerry? Is it
Just a spray, a misting spray. You know, there's a whole lot of misting spray designs you can get. There's ones that they use in restaurants and that around Australia at different occasions when it's hot in summer. It's just a fan on a pedestal with a 2 litre or a 4 litre container. Just one of those is very effective. Always dilute this stuff. If you're going to use it like that, dilute it 100 at least, 100 to 1 or 200 to 1. And the same thing with hydrolysate. How are we going for time?
20 minutes.
10
past
Okay, heaps. Might be. Anyway, so there's the seed microbiome. That's what I was talking about before. That's really worthwhile having a look at. I've got some copies of this presentation here if someone wants to take them home. I haven't got many of them.
Could we maybe get that sent out as well if people wanted these? Like, have you got a? Did you do a copy?
So yeah, I'll leave these with you here as a group. Okay. This was fleabane. We had an interesting conversation yesterday with a person who's using shit down south. This was fleabane. This was in Temora in 2017. Fleabane at that time, as you know as farmers, grows really well after wet weather. But down in Temora, because the soil in that area is absolute shit, they grow about that high, but they're only about a centimetre apart. But so it's blinding sheep, mismothering lambs. This process is really interesting because it'll go completely contrary to your thinking in terms of cutting hay. What you do is try to cut the fleabane when it's green and wet, and put 40 mils of inoculant into each bale and round bale it straight away. The whole thing about this composting process, when we composted about 1 million cubic metres after Cyclone Yara in Queensland, we didn't have a single fire. The reason you don't have a fire in a big pile or in a round bale is because it's too wet to burn. There's so much respiration happening in there because what you've done is you've used as broad a biological base as you possibly can. Because you've got that broad biological base, it's constantly respiring at some level. So yeah, we had in that instance no worries about the issue of fire, although stupidly, as you'll see, we created this triangle. And the triangle was the bloody thing we were trying to avoid in the first place. So what now we've been talking about is if you did fleabane weeds again, tend to use 2 bales with a gap in between or stand them on their end. But the interesting thing about this is instead of using what we used, which was a plastic weave, if you went back to the old hemp thing of just 2 hemp strands around it, bale it up and put it on top of a hill, then let nature do the distribution. Wait till it falls apart and let the stock and things move it around your property. But it means we could get, in this instance, a 100% seed kill. If anybody wants it, I can send you that paper.
How hot does it get to kill pathogens, like in the nappies?
To get to a point where the EPA will consider pasteurisation, which is AS 4454, it's 55 degrees Celsius. You'll notice in this thing that we start this afternoon, your temperature can go anywhere between 65 degrees to 70 something. So it can get very, very hot, way, way above where it needs to be for pasteurisation. And you won't, I mean, you can never guarantee anything to do with disease, and you might get a sparrow come past and poop on your compost and have a seed in its feces, and you'll get a weed growing out of it. I mean, you can never get a 100% guarantee, but we've never had any issues with any sort of disease in any of these processes, be it a hydrolysate or the composting process. This is just about the last slide, and I'll spend a little bit of time on this before we head off out to lunch, or just before we have lunch. It's making a hydrolysate, so it's basically using a protein source. I'll do the explanation later on, it's much easier. But what we're going to do now, David and Sue from Lamb's Thought will do all this. What I want you to do now is just get some sort of experience of how we make the inoculant. That's it. So, I never know, that always puzzles me because I never know what's going to come there. Again, we're trying to broaden the biological base as far as we possibly can. So what it means is when the aerobic phase starts, once the aerobic phase is completed and the pH drops to 4.5, you've got no bloody control over anything apart from keeping that cover on. So you're totally relying on nature working out what it wants to do with the process. But once you've initiated the process, it's quite comprehensive in what it'll digest. So what we're going to do is somebody can throw that. That's the inoculant, that's the base lactobacillus, and that's molasses. If somebody wants to put those 3 into that water.
Right. Thank you. So which is you like? That's this one?
Sorry?
Which kid was that?
No, I've just been asked about the basalt dust. Get it from anywhere, side of the road's fine.
So could the basalt dust be put in down?
Yeah. So what I want a couple of you to do is go outside and pick some plants, any plants. So what we're going to do is we're going to put phototrophic and photosynthetic bacteria into these 2 containers. Somebody want that?
Green ingredients, are we going?
Green ingredients, yeah.
Molasses and basalt.
That's molasses, that's molasses and basalt and lactobacillus. That's in there already, all right? What we're going to do when those plants come back is we're going to put these... Don't be too long!
Don't hurry the guy. So this is just plain water, not rose water.
No, this is right. No more. Stick your hand in it if you like. Sorry?
Do you want me to get a knife?
Yeah, stick your hand. Here, look.
Very fast. Would it be molasses?
Here's the moment. Oh, there you go.
And rats. Smart.
It's too bloody. Who got this water? It's too cold.
Like lactobacillus bait.
So there's 4 things. Off water.
Yeah.
That's right.
Just to align people's views, I will email all the materials that Jerry's talking about. So you'll have the recipe, you'll have the slides, everything that's available.
Yep.
No, all right. It's just water. That's right. You just get it. Molasses ends up everywhere.
That's it.
Anyway,
Yeah, just
where are the people with the green plant?
awesome.
What we're doing is taking photosynthetic and phototropic processes that are happening in the leaves of those plants, and we're actually putting them into this mix. So what you can do now is put these 3 containers. Oh, sorry, I just should mention this. Under normal circumstances, if you can, use seawater. This is as good as seawater. This is just rock salt. Just add a bit of water to it. Voila, seawater, yeah. That's all it is really. So And that could go in there really. So if you could put those two into that bag. Now the reason we're using these little bags, the reason we're using Hessian bag, and that I had a bloody hemp bag out in the rail out there, but somebody's taken it. Must be somebody a bit worried about flood. Oh, yeah. If you could bring that in, thanks. The reason that we're doing this is when I first started making this, we were just using grass for phototropic and photosynthetic, and as anybody who knows has ever run anything with a pump in it, everything just bogs up with bits of leaf and God knows what else. So these things, they're just a standard bag that you'd use in flood, and we use that in a 44-gallon drum or larger container. It's just the tea bag concept just saves you a lot of angst, and that goes into there. Now, under normal circumstances, we'd fill this up. Fill it up with water. Now this bag, have you got your bag in?
Trying to work out here at the end.
So what went in with the grass?
With the green plants, we had bran. Oh, keep this in mind too, if you can't get bran, porridge is just as good. We're using porridge in Samoa. They couldn't get the idea of bran. Anyway. So you've got and we couldn't get them to use blood and bone. So we got them to use dead fish. Just bones and shit from fish, chopped them up a bit. And that was their blood and bones, and the stuff was working perfectly. So it's a fairly forgiving process, but the biological base needs to be broad. Now what you need to do, once you put all those bits into here, is jiggle this for 5 days. After 5 days... Not consistent. I was going to say, you're right. No, don't do it for 5 days. Do it 5 days in a row. Kim, can you pass that the one with the pinkish tag on it? I'll get close. And what we're producing is this, which is spice inoculant. As you can see, it's slightly different from the base lab in terms of colour, and it's got a lovely, well, depends where it's got a nice smell and a nice colour. Depends where you get your favourite colours from. So that's what you're aiming to produce, and we'll use this out on the farm today for the composting process.
So you could just open the lid, give it a stir every day.
Open the lid, jiggle the bag.
Oh, okay. Yep.
Yeah, and then stick the lid back on. But you could go up to, there's no point, you might as well take this up to about 4 centimetres from the top.
Is the lid on tight?
If you put it in a compost aerator?
I wouldn't bother.
Okay.
Well, I mean, that's not hard to do.
No. But if you've got 5 days straight, the aeration.
Yeah, I wouldn't.
Will the aeration bugger it up or not?
Oh, I wouldn't. No, I wouldn't. Air's an enemy. What you're trying to do is when you finish your composting process, and I think people are quite wrong about the idea of making compost tea, because what you're trying to do, and as I said before, the second stage of the process is facultative. So facultative anaerobes are switching from aerobic to anaerobic.
Yeah.
If you force air through it, you'll eliminate anything to do with anaerobic.
That's right.
And so you don't want to do that.
Okay.
What you're trying to do is get that broad biological base and maintain it in whatever it is you're using as a seed coat or whatever you're using as a foliar spray on your crops.
Okay.
We'll try to talk about application rates, but there are 1,000 different opinions about that. Some people like Christine Jones will only use 5 to 20 litres per hectare of a foliar material. But I don't know what the people in Vermont are exactly using in terms of this stuff at the moment. But can we just temporarily, we'll switch over to hydrolysate because we've got to get lunch happening.
When you said, you repeat that
5 days.
process over 5 days, fresh vegetation each day?
No, don't change anything. Don't add it
in there.
You get water up to near the top of the thing if you can, but don't change anything.
Just jiggle it, just leave it.
Just jiggle it.
For about 5 minutes?
Yeah, 5 minutes is heat. You just put the lid on, don't put the lid on tight. Just sit there. Yeah, I nearly got knocked over by a bloody 1,000 litre IBC. If you put the lid on tight, it'll generate some gas. What you're trying to do, again, if you go back to making the lactobacillus, what you're trying to do with loose fitting lids is stop big animals like Drosophila and things getting in there, because they carry other biology with them. It's the same thing with this. After this is finished, after 5 days, you'll put it into a container. Michael, could you pick up that? There's a 15-litre drum of spice inoculant there. This, by the way, is due to have its 2nd birthday, I think, something like that.
July 24th.
Yeah, 1st birthday. Anyway, So it will last a long, long time after you've made it, provided you keep the air away from it. But once you've actually finished the making of the product, put it into something and put a tight-fitting lid on it.
How do you know when it's past its use by date?
Sometimes it'll smell,
Yep.
but then interestingly, if it starts to smell, restart the process by adding some more lactobacillus and some more carbohydrate. That doesn't always work, but I mean, if you know you're going to need an amount and you're making an amount of compost, make what you need for say 6 months or a year, and leave it at that.
Sorry, and what do you recommend to use as carbohydrate?
Molasses if you can.
Back to molasses.
Yeah.
Okay.
So we're just going to touch on the idea of, somebody could distribute those a bit more so people can see. So making a hydrolysate, which is the last slide we saw, right, from animals and things. In this instance of these animals are going to compost today, if you wanted to, you could take the livers and hearts and things out of them, put them through something like a kitchen whiz to turn them into a mash, and then put that in. The same thing applies, interestingly, to, I've made it from manure and pig manure, all sorts of different things. Anyways, what you need to make a hydrolysate is a protein source, and to that you need to add lactobacillus. You need to have a carbohydrate to run it in and to put some water in. So this is just a really simplistic thing concocted. So it needs to be put under a fermentation lock. So if you're used to making home brew, that's the sort of lock. Not that sort of bottle. I mean, you can use that sort of lock on a 1,000 litre IBC. It's sufficient just to let the air go out one way. In this instance, we've been using this in fairly remote communities because if you're in a place like Samoa, there's bloody bottles wash up all the time from the sea. And so it's easy to do that, it doesn't even have to have a second bottle, it can go into a cup of water. So to make a hydrolysate needs a protein source. What you're trying to do is you get that protein source, when it goes through hydrolysis, the proteins are broken back into amino acids and peptides. As a farmer, that gives you control over those amino acids and peptides. It's like you're going through halfway through the growth cycle of things and it gives you a degree of control. But it's a biostimulant. It's not trying to replace your agronomic advice or your agronomic skills, and it's not trying to replace your nutrient skills. Well, there's lots of arguments you could get into about biological transmutations. Woo, Kevran, people and that. But anyway, but if you look at the idea of what you're trying to do is break those proteins back to amino acids. Once you've actually got that functioning happening, it gives you a degree of control. Again, you'll find that process will drop the pH in this mix down to about 3.2, but if it goes below 4.6 pH, it means you've killed off any zoonosis, anything that's going to be potentially harmful to humanity. We've done it with a whole lot of different mixture of different materials. But all right, so you've got the protein source. You get your protein source in a container like this. Say you've got it to that level, you add 100% water to it, you add a fifth of the weight of the protein as the carbohydrate, and then you put in an amount of the amount of lactobacillus equivalent to about, I think it's about 7/10 of a litre, well 7/10 of whatever this one was. That's all it is, and it just ferments. After it's fermented, we've been leaving it to ferment for 4 weeks. The secret, however, is not the length of time, the secret is the pH. If the pH goes below 4.6, it's safe to use. But when you do use it, dilute it at least 100 to 1, if not 200 to 1. So, going back to this little beauty, this one's a bit stretched. So this is beef mince, just common butcher's beef mince. The experiment here was, could you use coconut milk to make base lactobacillus? And the answer is yes, you can. Could you use salt water? And absolutely yes, you can. So we've just had test results come back from Symbio and EAL on this product. I haven't seen the totality of them yet, but it's made a wonderful product. I'm more than happy if someone would like to take that home. It needs a home. But 200 to 1, 200 to 1, and it doesn't stink.
And that's what you're using as your foliar spray?
That's using as a foliar spray.
Yeah.
It's a hydrolysate.
That's fantastic.
Yeah, it's a fascinating process. But you know, it's about trying to cut fertiliser inputs and trying to cut the input costs that you've got in agriculture overall. So leave that alone. Take one of those if you're interested in hydrolysis. If you need more information, let Cheryl know and she'll write to me. I think we should stop for lunch. Keen on the idea of following what's happening in your compost piles once you start composting animals. This is a Geo something. A Rio thing. It's about, the thermometer itself is about $400 worth, I think. But the head on the thing is about $200 worth on its own. But I'll tell you, it's funny. You drop it on the floor or something, it's very good to have. But if you want to start following the temperatures in your mix, it's worthwhile having one of those. And keep in mind, when you do this stuff from this point on, if you're composting animals, you're essentially breaking new ground for yourself and for others. So try to make as many records as you can of everything. Try to write it all down and tell each other about it.
Can you explain how you use that in the pile?
Well, sorry, I should have taken it. This plastic tubing is just a plumbing device to protect it. So if you're using it in a just in a standard covered compost pile, poke it straight through the plastic and down as far as you can possibly get it, and just measure it from the same spot every time. It'll give you very, very accurate data on it. But write it all down and keep note. I'm going to leave this one. This is a little baby one, sort of $30 thing. It has pH and temperature, but it might be a handy point for Cheryl to start with your Landcare group. Also, too, I'd suggested to David Hardwick that Landcare groups like yours, I appreciate the fact that you're all farmers and you've all got to make a living, and you might think there's a huge amount of time that's going to have to be dedicated to this. First of all, it's not the case. To start off, putting a bit of rice in water is a doddle unless you're doing 1,000 litres of it. But also too, the next two phases are only a short amount of time. But if it did prove too much, can I suggest you think about the idea as using it as a Landcare fundraiser and nominate or get a group of people among yourselves who might want to make the product for your whole group and then sell it to each other for, I think, we're supposed to be making it in Samoa and selling it to somebody to make compost, and I think the price they came up with is about $5.80 a litre or something. But you can come up with a price like that if it relieves everyone else from the pressure of having to make the product. You could actually have and then sell it as a group fundraiser.
How much would you add, say, to a cubic metre of compost?
Sorry?
Of the biosphere?
Oh, sorry. You'll see this afternoon, 1 litre to every 10 cubic metres of compost. 1 litre of the spice inoculant to every 10, and it can be in any amount of water. But 1 litre, and the water, keep in mind, the water is the highway that the biology uses to get from one part of the compost pile to another. But 1 litre is sufficient for 10 cubic metres.
So Jerry, this is the one we use for inoculated compost, or
that's the inoculant compost. Yeah. This is a direct foliar spray.
You use that one in the hydrolysis.
That base lab.
That's lactobacillus, and you use that in the hydrolysate process.
Yeah.
But you also use the lactobacillus in the spice process.
Yes.
Same tent, different desert. Yep. Does that make sense?
So Jerry, you've done all this at 100 miles an hour. So where's all the info?
All the info, all the information. Are there any of my business cards left in? Do you know?
Here.
There's some business cards here. On the back of my business cards, my website, it's jerrygillespie.net. All of the information is there on the latest news page. And if for some reason or other you can't get it for some reason, I'd be amazed if you could make something that was poisonous. Even when it smells, you could throw some more lactobacillus and carbohydrate into it and kick-start it again.
So I've made 200 litres of black.
Yep.
I haven't opened it since I sealed it back in April. I didn't go to the next phase because I thought it had
and it shouldn't matter all that much. Temperature's not crucial, although if you're happy with the temperature, it's going to be happy with the temperature. So if you can do it in your house or in the shed. No, we had -8 last. But no, if it's just in the shed or something, it'll be fine.
It's just a little pack of
Yeah, absolutely. Don't stress too much about the temperature.
I gave some dead kangaroos a shower.
Oh, is that right? No, too much air on the end of the pile, the stuff didn't break down.
Yeah, right. Okay, perfect. Okay. Nicely basted on both sides.
What we're doing is working out how many animals we can fit onto this particular bed.
Yeah.
There's no specific ratio or anything. We're just dealing with whatever it's got, whatever material we've got, and whatever space we've got to deal with in terms of the actual cover sheet.
So
what we'll do now, once this is all spread out over this first layer of animals, it's all inoculated, we'll put another layer of animals on top of that. If I was applying it, I'd wait until the process was finished. Well, not finished in the sense of trying to leave it for a number of months if you could.
Yeah.
So that you then, I pursue the best of the compost in the middle of the pile and make a compost extract from that, not a compost seed. Make a compost extract that can be then used as a foliar or as a seed coat. It'll make a very, very high quality product. But beyond that, once you've actually managed to get the bones out, any distribution process you can use would be worthwhile. I would think that with the quality of compost that this should generate, a couple of handfuls there per square metre would be enough on any property basically. Because what you're trying to do is stimulate a biological process. You're not trying to deliver a nutrient, you're not trying to replace fertiliser, you're trying to stimulate what you've already got there. If you pump air into something and you've already tried to create a balance between something that has air and something that doesn't, where you've got factor of biology in there, facultative biology, you have to knock something off if you pump air into it.
Right, no good, I agree.
Yeah.
Just wondering why.
Yeah, it's just illogical.
I'm not a fan.
Yeah.
All that,
So it's a lot of,
you don't know what you're changing.
yeah,
You're
absolutely.
pumping oxygen in, you're feeding them, you don't know what you're doing.
If you were interested in the idea of making an extract just from that basis, you could actually put a container in, you could put compost into a container and just pump the fluid around in circles if you want to do that. Put down and stuff. With the document that I'd sent already to Cheryl, which is a GOAT document from an American university, it's about 6 weeks before these things should be broken down a fair bit. I would say 6 to 18 weeks, but because of the nature of the biological base that we've used, the longer you can leave it, the better. So if you're not in a hurry, as we were just saying, you could make a compost extract from the product and use some of that and then just leave the rest to sit with a cover over it.
And the bones.
The bones are always going to be a difficulty, but I'd suggest that once you've got the bigger bones and they're clear they're not going to break down, throw them into a fire bin or something, a 44 gallon drum with a fire into it, and just burn them so that they actually break down fairly readily. But I mean, you've got to be fairly fanatical to go chasing calcium and that sort of but it's possible. So most of the bones won't break down, although we did find with a small kangaroo when we first started using the process after 6 weeks, it's only a tiny animal, but only the hip joints were the only things that were left. The other thing that happens is at the end of this compost process, I've done a comparison between this and a straight aerobic composting process. This will give you 20 to 25% more. You have to remember that the composting process in regards to most waste management firms is a waste reduction tool. You're not trying to do that as a farmer, you're trying to maximise what you can get out of the pile. So this process is 25% better for you than a shitty old composting process that's just reducing stuff and losing gas to the atmosphere. Because you're saving all your gases, because you're not losing anything to the atmosphere, because you cover every bit of C that you don't lose or H that you don't lose, or all of that becomes a material thing that stays in your pile. So 20 to 25% more. I've got a document on that actually. Not very elaborate. So once you've actually made the base lactobacillus, it can be used in the extension of the spice compost process. It can be used to make a hydrolysate. It can also be used to keep odour out of toilets. It can be used underneath chickens to keep them healthier in chicken beds. And I would argue you can probably use it in dairies and things as well. And certainly you could actually spray it on a consistent basis in the stuff like piggeries to keep odour down in those sorts of areas as well. It's very good for odour control.
Okay.
We found that out again later.
Make a good pallet.
No, it'll be alright, it'll settle down anyway.
Yeah.
You can always come back later and just full burn the little bits.
Yeah.
If it starts flapping around, that's the only time. You just got to be a bit careful.
Put some more into the.
Yeah.
Just throw some more that direction into it.
Just turn it off.
Yeah.
That way.
Yeah, cook it overnight.
If you don't have a thermometer, let's just get a piece of Rio steel, the old half-inch money. Just stick it into the pile. If you pull it out and hold it longer than 5 seconds, it's not hot enough. So be usable in about 18 weeks, but I would recommend that if you can, you leave it for longer.
Yeah, sure.
But then also too, at an 18-week point, I was saying to somebody earlier, if you took some compost out of the middle of that, you'd find it to be very, very high quality. So I tend to make a compost extract from it. So a Hessian bag full of the compost and a 44-gallon drum, just dig it for 20 minutes or so, half an hour. And then use that as either a foliar or just as a biostimulant in a general broad sense. So,
And it wouldn't matter if you collected the carcasses over a period of time, if they sat around for a month, it doesn't matter the conditions necessarily, or?
what we found with the kangaroos when we used them in Bungadore is they're only about a week or 2 weeks old and they dried out incredibly quickly. They lose so much moisture. So if you can, use them.
So you just left the skeleton in there and with all of this?
Yeah, so
And,
it's not going to chew up much of the bones, even though it's a fairly aggressive process. So most of the smaller kangaroos, quite possibly there might be only just the hip joints left, but the bigger ones there'll be quite a bit of bone left.
Really? So that's interesting.
Well, you still
do lose so much bone in the small.
in a smaller one. But when you get the larger bones, I mean, if you're really fanatical about it, just throw the bones into a 44-gallon drum with a fire, and once you burn them down a bit, they'll crush up fairly readily. But it's still not a bugger. You've got other things to do on a farm that are more important than that, I'm sure.
Yeah, put the bones
I
in
I was just
the
wondering,
biochar.
use an old chaff maker.
Yeah, you really
Put
could
them
do.
through that.
Yeah, absolutely. Yeah.
But
all those combinations of things like biochar as well, you know, not difficult to make. You mix your compost extract or the compost product in with the biochar as well. And use it.
Yeah.
But if you put the bones in when you're making biochar, you actually put extra calcium into your biochar as well.
Particularly,
I hope it turns out to be what he
you don't
really
keep
enjoys.
dump bins on
I think
people
it
and
might.
expect them to learn things